Hello, math students. Mr. B here. All right, we're gonna look at graphing quadratic functions when the function is given to you in vertex form. So vertex form looks like this in the upper right here. F of x equals a times the quantity x minus h squared plus k. And the vertex is simply the h and the k, the ordered pair h comma k. Let's look at an example, a real-life example with numbers in it. So let's say we want to graph the function f of x equals the quantity x minus 3 squared minus 2. Where's the vertex? The vertex is located at h comma k, and in this case the h is 3 and the k is negative 2. It's a little tricky here. Notice that there's a minus in there. You might think, oh, the h is negative. No, when there's a minus there, the number after the minus is the h. So for example, if we had f of x equals the quantity x plus 3 squared minus 2, believe it or not, the h comma k would be negative 3, negative 2. So the h is negative here, in this case, when there's a plus. It kind of seems backwards, but what can I say? That's the way it goes. So positive 3 for h and negative 2 for k is what we have. Now, it's a parabola, right? And we know those are those U-shaped things. Does it open up or down? This number in front of the parentheses is what determines whether it opens up or down. If that a is positive, it opens up. If it's negative, it opens down. Well, I don't see a number in front of our parentheses that we were given, but we could say there's a 1 there, right? So here a is 1, and that's greater than 0. It's positive. So the graph opens upward. The parabola opens upwards. Now, I always like to draw a little thumbnail sketch of this parabola to determine what kind of intercepts there are. The vertex is at 3, negative 2. Maybe that's about here. This is the 3. This is negative 2. And it opens up. And I can quickly see that there are x-intercepts and there's a y-intercept. Here's our y-axis and here's our x-axis. So there's places where our graph crosses the x and y-axis. Not every parabola crosses the x-axis. There may not be any x-intercepts. So imagine a parabola that has a vertex that's above the x-axis and it opens upwards. This doesn't even have x-intercepts. We don't want to even look for them if they aren't there. All right, so first of all, the easiest one to get is the y-intercept. The y-intercept is located, it's where the graph crosses the y-axis, and the y-axis is x equals 0 for the whole y-axis. So the y-intercept is at x equals 0. So all we have to do is get the function value at x equals 0. So that would be the quantity 0 minus 3 squared minus 2. Simplifying a little bit, that's going to be the quantity negative 3 squared minus 2, which is 9, minus 2, which is 7. So our y-intercept is 7. I'll even write it on this little thumbnail graph here. Now, where are the x-intercepts? We have x-intercepts. These are the points where the graph crosses the x-axis. And the x-axis is y equals 0. Remember, y is f of x. So y equals f of x. That's going to be 0. So we're going to set our right side equal to 0. So we have 0 equals the quantity x minus 3 squared minus 2. If we solve this, we'll determine what those x values are. If you were to try to do that in the case where there aren't any x-intercepts, you would get imaginary numbers. You'd get non-real complex numbers when you try to solve that. And that would be a clue that, hey, there's no x-intercepts. But I always do the little thumbnail sketch, and I'll know immediately if there's x-intercepts or not. Like I said before, I don't even solve for x-intercepts if we don't have them. Okay, so one thing that's really nice is if we're given this form, vertex form, it's as if the square is already completed for us, if you remember completing the square. So don't multiply out the right side and use the quadratic formula or something like that. Just use what you've got. Look what happens if we add 2 to both sides. Then we're left with 2 equals the quantity x minus 3 squared. And we can use the square root property immediately to get this. Some people maybe like to see this flipped around where you have the quantity x minus 3 squared equals 2. Then we'll use the square root property to say that x minus 3 equals plus or minus the square root of 2. And then we'll add 3 to both sides and get x equals 3 plus or minus the square root of 2. So these are the x-intercepts of our graph. So let's make a nice pretty drawing of this situation, not just that rough thumbnail that we had before. So I'm going to draw carefully. 1, 2, 3 to the right, and 2 down. That'll tell us that our vertex is right here. We can easily find the y-intercept up at 7 on the y-axis. 3, 4, 5, 6, 7. There's that point. And now let's graph the x-intercepts. This is really approximately 3 plus or minus 1.4 if I just round a little bit. I don't need exact values to do a rough graph, or a halfway decent graph. So from 3 we need to go down 1.4, maybe that's there, and up 1.4. So this distance right here, I'm at 3 there to here, this is square root of 2 between there and there. And from 3 up to the upper x-intercept, this is another square root of 2 up from 3. Okay, so we're almost ready to graph this thing. I know that there's a symmetric point to this y-intercept. And remember, these graphs are symmetric. There's an axis of symmetry here. Axis of symmetry. And that axis of symmetry, of course, is the x equal 3 line. If I could write it right. X equals 3. So this point right here, the y-intercept, has a matching symmetry point on the other side. And since this distance is 3 from the symmetry axis to that y-axis, we need to go 3 up to the other one. So 1, 2, 3, that's 6. And we'll come up to there. Okay, now I have, look at this, I have 5 beautiful points to graph this thing with. So I'll graph the right side, and I'm going to graph the left side. I'm trying to draw that vertex nice sort of roundish at the bottom there, doesn't come down to a sharp V. It's curved, it's flat really on the very bottom, and have it curve up and around. So let's see, let's embellish this graph with some more details. How about the x-axis? I'll put a 0 at the origin, mark the y-axis, and I think we'll call it good right there. So I hope that was informative, and we'll see you in the next video.